So today we're going to see if we can write some equations from patterns. This is a very important thing to be able to do, and it's kind of tricky sometimes, and we haven't learned everything yet that later on in the next chapter we'll learn something that will be kind of helpful for us too. So sometimes a pattern can lead to a general rule. If the relationship between the domain and the range of the relation is linear, it means it's going to give a line when you graph it, the relationship can be described then by a linear equation. This is what we're going to use. The ratio, remember that's a comparison, of the range values to the domain values is constant, so it'll be the same. So that's what you're going to be checking to see if it's going to be an equation, and then you're going to use that to write the equation. So sometimes you have graphs you can look at or anything. I've just put everything in table form, so I've already put it in a table for you. So we want to look at the relationship of the x values. Well, what's happening going from here to here? We're going up 1. Are we going up 1 every time? Yes, we are. What happens here, going from 28 to 56? Well, you're actually adding 28 or doubling it. Here again, you're adding 28. So you want to make sure that that ratio is consistent, and it is. And remember, it's the ratio of y over x, or range to domain. So when we write our equation, we're going to start with y, and then we will write whatever this ratio is, right here in front of the x. So in this case, the ratio is 28 over 1 times x. And then what we do is we kind of check this to make sure it works, because some of them are going to work and some of them we might have to adjust a little bit. So if we would make an xy table for this and put these values, 1, 2, 3, and so on in here, would we get what we need over there? 28, yes. 56, yes. 84, yes. It checks out. So that would be my equation, y equals 28x. So you look to make that ratio, and you put it in this equation, y equals some number times x. Alright, so let's look at this one, and first we got to see if there's a pattern. So here, yes, we are going from 1 to 2 would be going up 1. Here we're going up 1, here we're going up 1. So yes, it looks like that's correct. Here we're going up 2 this time. 7 to 9 is 2, 9 to 11 is 2. So my ratio would be 2 over 1, which is just 2. So I would write y equals 2x. But if I try to test this, I put in a 1, I'm just doing a few of them just to try the test, put in a 1, 2 times 1 is 2, and I wanted to get 5, so it didn't work. If I put in a 2, 2 times 2 is 4, I wanted to get 7. Put in a 3, 3 times 3 times 2 is 6, and I wanted to get 9. So I'm going to need to make some sort of an adjustment, so I need to ask myself, what do I do to this number 2 to end up getting this number? Well, I'd have to add 3. Does that work? 4, add 3, yes. So the adjustment is I need to add 3 to everything over here. So that leads to this equation. So it's a little trickier there when it doesn't work. You got to try to test it out and see what happens. Alright, don't give you very many here, so let's see if we can figure something out. So again, going from -1 to 1, what am I doing? I am adding 1. 0 to 1, I'm adding 1. What happens here? 2 to 0, I'm taking off 1. 0 to -2, I'm subtracting 2. So my ratio is -2 over 1, which would just be y equals -2x. So we need to test it to see if we need to make any adjustments. So again, I'm putting -1, 0, and 1 in here. So if I put a -1 in here, I'm going to get +2, which is what is over there. If I put a 0 in here, I'm going to get 0. If I put a put a -1 in here, I'm going to get positive. Oh, sorry, I'm supposed to be putting a +1 in this one. Put a +1 in here, I'm going to get 2. So it does check out. Sorry, I got a messy equation there. So my equation should be y equals -2x. And we have one more example here. So again, let's establish what's going on here. Going from -2 to 0, I would be adding 2. 0 to 2, I'd be adding 2. What happens here? I'm subtracting 1 every time. So my ratio is -1 over 2. So you can get fractions. So -1/2 x. So now I want to see if that would work. Hopefully I'll put the right terms in this time and not mess up. So if I put a -2 in here for x, half of 2 is 1. Negative times negative would give me +1. Not what I wanted. If I put a 0 in, I'm going to get -1/2 times 0 would just be 0. If I put a +2, half of 2 is 1, and the signs are different, so I'd get -1. So I didn't get what I wanted, so I need to ask myself, what can I do to make this look like that? Well, what do I do to 1 to get 0? I would subtract 1. So it looks like I'm subtracting 1 every time. So So I need to add that to my equation to get my answer. So that would be it.